Well, good morning, good afternoon, and good evening. Welcome to the Crazy Hat Chemist. So here we go with another video on learning chemistry. Remember, the Crazy Hat Chemist is your source for real chemistry, learning how to do real chemistry. All right, so today what we're going to be covering is a worksheet in electrons in atoms. So that is electrons in atoms worksheet. And we're going to be covering a number of different problems here. So in order to cover this, we are going to, there's a front and back page. There's 2 pages of this. We got a lot of stuff to cover. In order to cover this, we absolutely most certainly need a periodic table. And I will be using this periodic table right here. It is the same periodic table that comes from the SAT subject test. When they did have that. So maybe that will come back in time when actually we go back to doing real learning of real chemistry. So otherwise, here we go. So let's start off with the first problem. It says, and there's a set of 10 problems here. The first 10 problems, it says, what element has the following set of 4 quantum numbers for its last electron? So one of these key words here is last electron. So I'm just going to highlight that here because that's important for this problem here. It's the last electron that we're looking for. So in order for us to do this, we're going to take just a pause from this here. I'm going to peel this away. And what we're going to do is we're going to pull out a periodic table and we're going to label it with all the quantum numbers. So this is going to be critical for our understanding of this entire unit. And I'm going to refer back to this frequently. So here we go. We have a lot of different sections of this periodic table. And the periodic table is truly a thing of beauty. It really is a thing of beauty. And I did not understand this until I started teaching. And so I'm here to spread the word that the periodic table is truly a thing of beauty. And how is it a thing of beauty? That's what I'm here to answer, that question right here. So here we go. That's right. We're going to answer, how is the periodic table a thing of beauty? So one of the first things that we're going to do is we're going to draw some lines on our periodic table. We're going to be drawing lots of lines here. Okay, so here we go. Our first line is right here, and it's a line of separation with types of different orbitals. And so everything here is an s-type orbital. S as in sharp, that is. And this helium actually falls within an s-type orbital pattern as well. So that is everything within this boxed section. I'll leave a little bit of space there for helium because it does belong in there. So helium would be right here, if you will, for this activity of an s-type orbital. So we're going to slam the helium off to the left-hand side. All right. The next type of orbital that we will be discussing here are the p-type orbitals. And so I'm going to box those out here as well. Okay, and let's see, my periodic table does not have all the current elements here in it, but if it did, then there would be all the way up to 118. And those would be in this not yet named section. So that's what that would be right there. Okay, P is for principle. So when the atomic theory was being discovered, then they were looking at diffraction grating and P, that is P. So these are P-type orbitals. I'm going to highlight that in a little bit brighter kind of, there we go, there, that's P-type orbitals right there. These are S-type orbitals, just so that you can see those certainly clearly. All right. And now what we need to do is we need to get another color, and that will be the d-type orbitals. And that would be right here in this section right here. The d-type orbitals are for the transition elements, okay? That's in the middle of the periodic table. The D's are in the middle of the periodic table. Those are the transition elements. Absolutely important, okay? And let's label this as well. So these are d-type orbitals right there. Okay, and then we will do one more, and these will be f-type orbitals. So these will be F right here. And these are going to be all the known elements at this moment in time. Of course, as science progresses, we will make new elements, but we have not made anything beyond 118, which would be right here in this spot right here. So we actually have that one named already. Okay. So you do have to be very, very careful in doing this periodic table, and because you do need to make sure that you are looking at the correct periodic table. Some textbooks have different kinds of periodic tables and they will differ, but they should be similar to this. Where they differ is that the LA is down here and the AC is down here, and those are actually D's and not F's. So this is one of the reasons why I really truly like this periodic table, is because it really does have all the elements in their proper location. All right, the next thing that we're going to do is we're going to do some labeling on the side here, and this will be the principal quantum number. Okay, so the principal quantum number here is on the far left-hand side. That is a 1, a 2, a 3, a 4, a 5, a 6, and a 7. And the principal quantum number is n. So n is the principal quantum number, so this is n. So these are the n values, all right? So one other thing here that we're going to label, and so we have 4 quantum numbers. There's n, there's L. L is the type of orbital. So when L equals 0, it's an s-type orbital. When L equals 1, it's a p-type orbital. When L equals 2, it's a d-type orbital. And when L equals 3, it's an f-type orbital. So I'll just highlight that in each one of these sections. I know it's a little bit difficult to read, but I'm going to write out a table that will have all that in just a few moments here too. So those values will be on this little table that I'll draw, and that will be an important thing to note and memorize. And one other thing to note with this is that this table, this like little T-chart, it does continue. It goes beyond what I'm going to write here. And that would be something to be particularly interested in too. So L values, 0, and the orbital type, so orbital. And that would be an S-type, and the number of quote boxes, and we'll come back to this, and these boxes are representing orbitals, and this will be 1. Okay, the next line will be an L of 1, and an L value of 1, and that is a p-type orbital. Number of boxes that we're going to draw is 3. And the L value of 2, and that is a d-type orbital, and the number of boxes is 5. And then an L value of 3, and that is an f-type orbital, and the number of boxes is 7. Okay, for our current periodic table, this is all we have. Okay, what I'm going to do is draw a line in the sand here, and this actually does continue. You should notice that these are odd numbers, 1, 3, 5, 7. The next number would be 9, and this number here of L would be 4, and that's a G-type. Everything after F is going alphabetical in order. So if you're looking for beyond this, and your instructor was looking for beyond that, I've just given you the pattern of which you can follow for that, and you should be able to follow that pattern. All right, so we have the n value, that's the principal quantum number. Then we have the L value, that's the type of orbital. And now we're going to have the m sub L value. And I'm actually going to write this here off to the side here, m sub L. And what we're going to do is we're going to divide each section into half. And I'm going to start off with the p's. So I'm going to divide this into half, just like this. So there's 1, 2, 3, 4, 5, 6, and I have 3 on one side, 3 on the other side. So this is not a number line. Don't mistake yourself for that. But if you draw a number line, then it will give you the m sub L value. So 0, 1, and -1, right? The middle number on the number line is 0, and this is a 1, and that it to the left is a -1. And then we'll repeat that, -1, 0, and 1. Okay, and then we're going to do the same thing with the s-type orbitals right over here, and we'll draw a line. And just so that we know, the m sub L values are the 3D orientation of the orbital along the XYZ axis. So this is really like px, py, pz. So it is not a number line. Don't mistake yourself. It is not a number line. But if you imagine it as a number line, then we can actually get the correct quantum number. There are 10 spaces here, so I need to count 1, 2, 3, 4, 5, and then draw my line in the sand, being half on one side, half on the other. and my middle box is a 0, and then I have 1 and 2, and -1 and -2, like that. Again, that's a 0, a 1, and a 2, a -1, and a -2, just like that. Then I have 14 here, so that's 7. Half of 14 is 7, that is. That's 1, 2, 3, 4, 5, 6, 7. And so I'm going to draw a line right here, right there like that. And these would be the m sub l values. And the middle one is 0, then 1, 2, 3, and -1, -2, -3, -3, -2, -1, 0, 1, 2, and 3. All right, now we're going to have one more quantum number. And so the three quantum numbers that I have written thus far, N, L, L, and M sub L, these represent the orbital, its type of the energy level, the type of orbital, and its orientation along the 3D axis on an XYZ plane. The next quantum number is M sub S, and the M sub S is only one thing, and that is the spin of the electron. That's it. That's all we're looking for, is the spin of the electron. Okay, so what we got is our first half and our second half. Okay, so the M sub S values is going to be +1/2 and then -1/2. Okay, I'm going to zoom this out a little bit so you can actually see what I wrote down there. Okay, so that's M sub S is +1/2 and then -1/2. So there's another advantage of writing these in halves. In like, you divide this section into half, you divide this section into half, just like this. And the M sub S values, all these are +1/2, and these are -1/2. And then same thing here. The first subset is +1/2 for the M sub S values, and then the second subset and M sub S values is -1/2. And then I'll go down here and I'll write these down at the bottom. So this is M sub S of +1/2, and then M sub S as -1/2. So there we go. Now we've got the whole thing written down just like that. Okay, perfect. So this is really why the periodic table is organized and looks the way it does. Why does the periodic table look this way? So here's really and truly why, and that is the periodic table is principally the first level of organization is the atomic number, which is the number of protons, which if you remember from our AXZ notation, the Z is the atomic number, the A is the mass, and so Z is the atomic number, and that represents the number of protons. So the first organization of the periodic table is atomic number. So that's why the periodic table goes in the following organization pattern. And I'll draw this in orange here. So that's A1, A2, A3, A4, A5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, etc., right? That is the primary principal organization of the periodic table. Thereafter, it's by quantum numbers. And you can see how nicely organized the periodic table is. We got s-type orbitals, including helium. We got p-type orbitals. We got d-type. We got f-type. Okay. And then we have, so of those types of orbitals, they're organized according to the L value of the quantum number, the second quantum number, the L value. Okay, and then we have the M sub L value, and that's, we can imagine it as a number line, but please don't tell your college professor that. It is not actually a number line. It's the XYZ axis along the 3D orientation of a three-dimensional object. That's what's most important. All right, then we have, so that's the M sub L value is in blue right here. Then what we have is the M sub S values, and that's the spin of the electron. The first half is positive, the second half is negative. So the spin of the electron is +1/2, and that will relate to a up arrow. And I just call this, and then the -1/2 is a down arrow. This is when we do orbital box diagrams. So this up arrow is going to heaven. That's why it's positive, because going to heaven is positive. When the arrow is down, that's -1/2, and that's negative. That's going to hell. We don't want to go there. That's negative. Okay, this gives you an idea of the quantum numbers. Now I'm going to have one other thing that we're going to write on here just because we're going to come back to it frequently. And let's see, what color shall I use here? I'm going to do this in black here, hopefully. Yeah, I got a black Sharpie. We're going to do it in black. All right, so here's what we're going to do. We're going to take these weights off, and we're going to write down the valence electrons. So the valence electrons go with the group. So this is group 1. So this is 1 valence electron. This is 2 valence electrons. 3, 4, 5, 6, 7, and 8 valence electrons, excluding helium here in this example, because there's only 2 electrons in helium. And then we have what I call, this is how I call it, this section right here, the D's and the F's. So if you are within the D's and the F's, I think this looks like, to me, this looks like not just a shoe, but a boot. And so how many boots do most people wear? 2. So how many valence electrons in any one of the elements that ends in a D or an F? 2 valence electrons. By the way, that is pronounced valence and not valence. That's to go over your curtains of valence. We're going to have one other thing here that we're going to do, and then we're going to do some folding. So what grade do you not want to get in your chemistry class? That is an F. So we're going to get rid of the F's. That's what I like to tell my students. We like to get rid of the F's. Now, that's, of course, up to my students to get rid of the F on their part. What other grade do we not else want to get? Well, we don't want to get D's, right? All right, let's continue this. So we got rid of the F's. So the other grade that we don't want to get in a chemistry class is a D, because that's not really passing in my book, even though some people might think so. So we're going to get rid of the D's as well as the F's. So we're going to fold those out. So what we have done is we have folded out so that we can see the D's. But now what we're going to do is we're going to squeeze this together here. And so now what we're going to see is only certain two groups here. And of course, I'm going to use my little paperweights here to nail these babies down. But what you see before here are only the S and P type orbitals. Okay, with the S and P type orbitals, removing the F's, remove the fundamental, the F, removing the D's, the diffuse, we have satisfactory passing grades in chemistry. That is sharp principle, satisfactory passing grades in chemistry. This group of elements right here that you see before you are called the main group or the representative elements. So the main group or representative elements, that's what you see before you. You should also be able to see the valence electrons, which are in black at the top. So the valence electrons are 1, 2, 3, 4, 5, 6, 7, and 8. So how many valence electrons in argon or xenon? 8. How many valence electrons in fluorine? 7. How many valence electrons in iodine? 7. How many valence electrons in potassium? 1. How many valence electrons in beryllium? 2. How many valence electrons in germanium? 4. How many valence electrons in carbon? 4. How many valence electrons in aluminum? 3. How many valence electrons in nitrogen? 5. How many valence electrons in oxygen? 6. Okay, so these are the main group or the representative elements. What I've done is folded out the D's and the F's. So I'm going to unfold this again. And now you can see clearly, hopefully, that if we got rid of the S's and P's, the satisfactory passing grades in chemistry, which we don't want to get rid of those, really, okay, what we're left with is the D's and the F's. And the D's and the F's are in the boot. So how many valence electrons in titanium? 2. How many valence electrons in iron? 2. How many valence electrons in gold? 2. How many valence electrons in hafnium? 2. How many valence electrons in uranium? 2. How many valence electrons in berkelium or californium or einsteinium or fermium? 2, 2, 2, and 2. Yet again, how many valence electrons in tungsten? 2. All right, hopefully you got that. So this is something that you really should be doing. What you need to be doing is you need to take a blank periodic table and you need to label the periodic table with the principal quantum number, that's n, 1 through 7. Then what you're going to do is label up the periodic table with the L values with this right here. Then you're going to do the M sub L values and then the M sub S values. Now there's one more thing that we need to add to this to make it really totally complete. Okay, and that is this D block. This D block right here, their N value is 1 less than the period. So it's in period 4, and so that would be a 3. So this is really a 3D. Okay, and so that same thing would correspond to the rest of the Ds. So this is period 5, and this would be a 4D. Period 6 would be a 5D. Period 7, this would be a 6D. So all the Ds are 1 less than the period. Also, in addition to that, you should see that these numbers 57 to 72. So there's a block of numbers that are in between that, and that would be 58 all the way to 71. These are the Fs. The Fs are 1 less than the Ds, 4, or 2 less than the period, 6. The Fs are 1 less than the Ds, that's 89 to 104. There's a block of 90 to 103 that fits in here, right in this spot, right there. And these are the 5 Fs. All right, so hopefully you see that. You can see that also when you fold it as well, like what we did before. Okay, so all the quantum numbers are written down here for you. You really need to study this and learn this, and you're going to take probably 5, 10 periodic tables, and you're going to write all these quantum numbers down on that piece of paper, on that periodic table, and you're just going to go for it. And then you will have all your quantum numbers written down and understood and memorized. All right, so that's the first thing that you need to do. All right, I hope this was helpful. These are all your quantum numbers, and we're not getting to the answers to the electrons and atoms worksheet, but what we're going to do is we're going to wait for another video to answer that. So this first thing is truly just going over the periodic trends in regards to quantum numbers. All right, so this is all about quantum numbers. I hope you have a good morning, a good afternoon, and a good evening. See you later for now. Bye for now.